So in this video, we are going to discuss the concept of relative speed. This concept can be used to solve many CSAT problems in a very short time. So you can also do without this concept, but knowing this will come in handy to uh, solve some questions in a very short time. So if you solve all the CSAT problems that in the previous year CSAT problems, you can see many questions repeatedly comes that uses the concept of relative speed. So what is this concept? So whenever relative speed can be used whenever there is two objects, people, that or vehicle or anything, that two things that moves either towards each other at two velocities. It is the first case, or moves away from each other like this. So they are moving away. They say, sorry, these two people are moving away from each other at two velocities in different directions. So the two cases are either moving towards each other or moving away from each other. So in relative speed, what we do is we make one person stationary and think from the perspective of the other person. So actually this person is moving towards this person, but we are assuming these are two persons. It could be a car, it could be uh, um, uh, just our hand of clocks, anything. It could be any object, people, or anything. So uh, uh, in actual scenario, although they are moving towards each other, we will assume that first person is is stationary and think from the perspective of this person. So if you think from the perspective of this person and assume that this person is stationary, what happens is this person is moving at a much faster pace towards this stationary person. So though to be exact, at a speed of v1 plus v2. So since we assume that this person is stationary, when they are moving towards each other, this person will be moving at a much faster pace if you assume that this person is stationary. I'll give you an example. Say there is, to explain that concept, say this is 100 kilometers and there is a car here that moves towards at 10 kilometer per hour, and say there is a car from here that moves at 30 kilometer per hour. So what happens after 1 hour? We'll see. After 1 hour, this car traveled 10 kilometers since its speed is 10 kilometer per hour. So from this point it traveled, and let's say it reached here, 10 kilometers. Let's call this A and this B. So A reached 10 kilometers and A is now here. Now B, what about B? In 1 hour B traveled 30 kilometers. So say B reached here and this is 30 kilometers. Now the distance between them, since A traveled 10 kilometers and B traveled 30 kilometers, have reduced by 60 kilometers. There is only 60 kilometers between them now. Now let's think about the scenario where we assume this person was stationary. If we assume that A hasn't changed his position and B is traveling, covering this 100 kilometers with a combined speed of 10 plus 30, 40 kilometer per hour. What happens? After 1 hour, B will reach some 40 kilometers here, and total there was 100 kilometers. So B traveled 40 kilometers. So what is left? 60 kilometers. So if you see, in the case where we placed A stationary and added the velocity of A to B and made B move towards A at a combined speed, at the end we will get the same distance between them, 60 kilometers. Even here it is 60 kilometers between them. So that's why this relative speed works. In the perspective of B, when B looks at A, when B is traveling at a speed, combined speed, the distance between A and B is getting reduced at a speed of 40 km per hour. So the distance between them, is getting reduced, that is at a combined speed of 40 km per hour. So A's location is actually is moving, but in the perspective of B, their distance is reducing at a combined speed of 40 km per hour. So how we can use this? Say in a question, the person is asking, two people are moving at a speed, so there is 100 km between them. A person is say two cars is traveling at a 5 km per hour speed, and this car is traveling at a 15 km per speed. So at what time they meet each other, at what location they meet each other, or at what time they meet each other? When we use relative speed, we will assume that A is stationary. We can assume B is stationary also, it doesn't matter. So we will assume one person is stationary, one car is stationary, and add the velocity to B. So B is now traveling at a speed 15 plus 5, 20 km per hour. Okay, and that what is the distance that needs to cover? When they meet, what happens? B will cover all this 100 kilometers and reach here. A is stationary, we don't have to worry what the exact location of A is. The distance between them is closing, and B will cover at a combined speed 20 km and covers this 100 km when A and B reaches. So that is the only thing we need to consider. So we can easily see, if B is traveling at 20 km, 20 into T is 100 km, means T is 5 hours. So we will get, after 5 hours they will meet each other, and we can easily also, this is the time. If they are asking time, we will quickly find the answer. And if they are asking at what point from the initial location A will meet at B, then we already know that A will be traveling 5 hours when they meet. So A will be traveling 5 hours when they meet. So from this point, 5 into 5, A has traveled 25 kilometers. So actually A has traveled 25 kilometers when they meet, and B has traveled 75 kilometers when they meet. So A will be meeting here. So when we have found out the T, then it is very easy to find the location where they meet also. So this is how we solve questions in the relative speed. This is the first scenario. Now we have another scenario, as I said before, when they are moving away from each other. So we'll consider that scenario when they are moving away from each other. So there is one person here, A here, and there is one person B. Sorry, not away from each other. There is no scenario like that. So they are moving in the same direction. So earlier they are moving towards each other, but now they are moving in the same direction. So this is V1. So this is V2. They are moving in the same direction. So in such scenarios, so I made a mistake here. V2. They are moving in the same direction. So they are moving in the same direction. So when they are moving in the same direction, we'll again assume. So if this is the scenario, if the question is like at what time they catch up or something like that, V1 has to be greater than V2, right? Otherwise V1 and V2 will never catch up, and V2 will the distance between them will keep on increasing. So there is no question possible in such scenario. So the only possible scenario is V1 is greater than V2, and in such scenario, again we'll make this person stationary. If we make this person stationary, actually he is moving, but we will assume that this person is stationary. So, and we'll think from the perspective of this person. So as far as this person is considered, he is moving towards this person at a combined velocity of v2, since v1 is greater than v2, v1 minus v2. v1 minus v2. Earlier, when they moved towards each other, it was v1 plus v2. Now, since they are moving in the same direction, their combined velocity becomes v1 minus v2. I'll just explain with another example to make it clear. Say there is 100 kilometers between them, and there is a car that is moving at a speed 20 km per hour, and there is another car which is moving at 50 km per hour. Let's see what happens after 1 hour. After 1 hour, this is the original position. This car has traveled and reached here 20 kilometers. Since its speed was 20 kilometers, this car has moved from its original location to 20 kilometers. But this car has moved 50 kilometers. So originally 100, so almost half distance it covered and reached here. So we'll call A, B. B has reached here. A is now here. So this is 50 kilometers and this is 20 kilometers. So from the perspective of A, after 1 hour, the distance between them has become 50 plus 20, 70 kilometers. So earlier I said we can make one person stationary and assume that they are traveling at a speed v1 minus v2. Then what is that case? This is 100, and we assume that this person is stationary, and this car is moving at a speed 50 minus 20 at a speed 30 km per hour. So after 1 hour, this person travels 30 kilometers and reaches here 30 kilometers. And what is the distance between them? 70 kilometers. Since total distance is 100, 70 kilometers. So see, as you see, same concept, but when the two person or two objects are moving in the same direction, we will have to use v1 minus v2 and use that as the relative speed and apply the concept. So that is why this concept was. So this is the basic idea of relative speed. And here also I will just explain one example question. In the second scenario, say a person is A, there is person B here 100 kilometers apart, and this person is traveling at 20 km per hour, and this person is traveling at 30 km per hour, say. So question is, from this point, if the distance between them is 100 kilometers, if A is traveling 30 km per hour and B is traveling 20 km per hour, at what time and what location will A catch up with B? So at some point they catch us up, and we have to find at what point they catch us up. So we will apply the relative speed. We will assume that B is stationary, and by catching up, we means A travels with the relative speed and covers this 100 kilometers and reaches here, right? B is stationary. So if we find out the time taken by A at a relative speed and to closes this 100 kilometer, then that will be the same time in the actual scenario where A and B meets at some point like here. So we'll see. So relative speed is 30 minus 20, 10 km per hour. 10 into t, we have 30 minus 20 relative speed v1 minus v2. 30 minus 20 equal to 10. So 10 km A is traveling. 10 into some time t A takes to cover 100 kilometers. So 100. So t is 10 hours. So totally 10 hours A will take to catch up with B. So in actual scenario, once we get 10 hours, we know that So this is 100. This is A. This is B. Since with 10 hours, A travels 30 into 10, 300 kilometers. So 200 kilometers. Totally, A has traveled this much distance when they meets 300 kilometers. How did we get the 300? 30 is the speed into time, we know 10 hours it took. So B traveled at 20 kilometers. So 20 into 10, 200 kilometers B traveled. So that is right. See, if you see from this point, B traveled 200 kilometers when they reach here. This is the point they catch us up. So from the starting point of A traveled 300 kilometers when they catch up, or B traveled 200 kilometers when they catch up. So we got time and the total distance and everything very fast. Once you start using this concept, you will understand how fast we can apply this concept to solve. So there, I will also explain a different scenario in the clock case. In certain questions, we'll have clock problems. Clock problem is also a problem where we can use the relative speed. In clock questions, we'll have a hour hand and there will be a minute hand. Right? So hour hand, minute hand will be traveling in the clockwise direction. Similarly, our hand will be traveling in the clockwise direction at a much faster speed. So if you see, this is exactly like two people traveling in the same direction, and we can use the relative speed concept. So I'll just explain how. Speed of minute hand is, so it travels 360 degree in 60 minutes. So in per minute, if you see how many degrees, if you see 360 degree in 60 minutes by 60, so 6 degrees per minute is the speed of our hand. And similarly, speed of our hand is, it travels 360 degree in 12 hours, right? If you see 12, 1, 2, 3, 4, 5, 6, sorry, 7, 8, 9, sorry for the unequal distribution. Okay, anyway, for our hand to travel from this position and complete 360 degrees, it will take 12 hours. So that is 12 hours and 360 degree, when we calculate in minutes, 360 by, instead of 60 minutes we have 12 hours. So 12 hours into 60, we converted 12 hours into minutes, so we have 12 into 60. So so this becomes 6 by 12, 1 by 2 degrees per minute. So this is the speed of our hand. So it's like this is V1 and this is V2. So if you ask what is the relative speed of minute hand compared to this hour hand, is V1 minus V2, which is 6 minus 1 by 2, that is 11 by 2. 11 by 2 degrees per minute. So this is the relative speed. And how can we use, and one simple question will be like, now our hand is here, and hour and minute hand is like this. So 1, 2, and this is 3, right? At some point it is like this. Now at what time will they overlaps again? So if the question is like that, we can use the relative speed concept. We can make the hour hand stationary and just move the minute hand. And at what time do they overlap? They overlap when they travel this 360 degrees. So we know that relative speed is 11 by 2, and we can use that 11 by 2 degrees per minute into t is equal to 360 degrees. Then t equal to 360 into 2 by 11. So this much minute will they take to from this point to travel 360 degree. So we can solve questions like that. So many such questions come in the exam. Another type of question will be, there is a park where two people are running. One person is running in this direction and another person is running in this direction. How many times do they overlap in such minutes, in a given time frame? So all such questions can come. So we can, once we understand the concept of relative speed, we can use this concept to solve many questions. So if you have any doubt in this, just comment under this video. I will try to explain more or do another video if it requires. So do as much as problems that uses relative speed, and you will start to use this concept, and you will get to answer in a very short time. So that's what the exam requires. So this is the concept. I hope this was helpful to all. Thank you.